Hi, welcome to this lesson on number patterns, arithmetic series. We're having a look at the first formula of an arithmetic series. So, like we said, using Gauss's logic, we can formulate a general formula for the sum, or another word we use is series, which means the same thing, of the first n terms of an arithmetic sequence. So just like Gauss did, we're going to list out the terms in order. So we're going to call the sum of the first n terms capital S sub n, and that's going to be equal to the first term plus the second term plus the third term plus the fourth term all the way up to the nth term. And that's exactly what I have listed out here. The first term, so recall the general term of an arithmetic sequence, a plus n minus 1 times d, where n is a natural number. So for the first term, if I plug in n equals 1 here, 1 minus 1 is 0, so I'm just left with a. Second term, t2, if I put in 1 here, I'm going to get t2 equals a plus 2 minus 1 times d, while 2 minus 1 is just 1, so it's a plus d. That's the second term. For the third term, same thing. If I put in 3, it's going to be a plus 3 minus 1 times d. It's going to be a plus 2d. All the way up to the last term, which is the nth term, which is a plus n minus 1 times d. Now, just like Gauss did, that genius move, we're just going to write the same sum backwards. That is it. So I start off with Tn plus Tn minus 1 plus all the way up to T3 plus T2 plus T1. Just to show you where you get that a plus n minus 2d, well, I'm looking at the term just before n, so that's going to be n minus 1. So if n was 7, then the term just before T7 is T6, so 7 minus 1 is 6. So the n minus 1 term, I'm just going to replace wherever there's an n with an n minus 1. So it becomes a plus, now instead of n, I'm going to write it as n minus 1. And then don't forget there's already a minus 1 in that brackets there, times d. So that's where I get a plus. Well, I'm going to have n minus 1 times d. But minus 1 times, minus 1 minus 1 is just minus 2. So that's where I get that a plus n minus 2 times d from. That's where this is coming from. Okay, so what did Gauss do? He said, well, let's add both of these equations together. So on the left-hand side, I have Sn plus Sn, right, which will just give me 2Sn, because they are like terms. Then what does this constant number look like each time that we're going to add? Well, let's look at the first one. It's going to be a plus n minus 1 times d. So removing the brackets now, I get a plus n minus 1 times d. Well, a and a are common, so I get a plus a is 2a plus n minus 1 times d. And that's exactly what I have in this brackets here. And if you look, and if you keep matching the pairs and adding them together, you'll get the same thing. So let's look at t2 plus tn minus 1. Okay, well, in that case, let's just clear up things here a little bit. Okay, so I'm going to do t2 plus t sub n minus 1, because those are the matching pairs that we are adding here. All right, so let's just do an arrow there to show. So it's a plus d plus a plus n minus 2 times d. Okay, the algebra works out nicely. We should get the same term in brackets again. Well, it's going to be a plus d plus a plus n minus 2 times d. Well, the a and the a are like, so they're definitely going to give me 2a. But now look at this. To try and solve for d by itself, what I'm going to do here is I'm going to take n and distribute it out to the d, and then negative 2 and distribute it out to the d. So don't forget I have this plus d here, plus n times d is just nd, and negative 2 times d is negative 2d. So I'm going to look at these two guys here, d and negative 2d. Adding them together, I'm left with negative 1d. So 2a minus d plus nd. Okay, so all I did was just add these two like terms together. D and negative 2d, when put together, is left over with negative 1d. Now here, I'm going to see, well, d is common to both d and nd. So I'm going to pull out a common factor, so plus d, and well, this is going to be negative 1 and plus n. Okay, but I'm going to be smart, so I'm just going to rearrange that inside brackets. It's going to be 2a plus. Instead of negative 1 plus n, I'm just going to say n minus 1, which is the same thing, right? Positive n minus 1, and that's times d. But look at that. That is exactly this term here in brackets again. So when you match the pairs forwards and backwards, you're going to constantly get the same term coming out. 2a plus n minus 1 times d. It looks very, very close to the general term of the arithmetic sequence, doesn't it? It's just missing that little 2 there in front. So it looks very similar, but it has a 2 in front there. So how many times am I adding up this same term we're getting? Well, there are n number of terms here that we've added together in terms of the matching. So this is going to be n times this same number here. And that's where we get that n times 2a plus n minus 1 times d. And lastly, to get rid of the 2, we divide both sides by 2, and that's where you get this n divided by 2 term here, and times it by that entire square brackets there, 2a plus n minus 1 times d, where n is a natural number. This is the first formula of an arithmetic series, and it's the most general formula of an arithmetic series. We're going to be looking at how we can simplify this series a little bit more in the next lesson, but to use this series, we had to make a quick remark. 1. To use this formula, you need to know the first term of the sequence A. You need to know the number of terms that you're adding up, so n, and you need to know the common difference d. So if you know those 3 pieces of information, you can always use this arithmetic series without any problems. All right, so this is the derivation of the first formula of an arithmetic series, which is the most general formula. Okay, I'll see you in the next one.